Using the given information, we are asked to find the length PQ. We have two different solution methods for this, and let's start with the first one. First, draw a perpendicular from point Q to bottom of the square. Notice that this shaded triangle is given to be isosceles. So this red line segment must bisect the base line segment. We know that the side of the square is 7 units, so these line segments should be 7 over 2 units. Now let's draw this perpendicular from point Q. So this part will also be 7 over 2 units. Since the orange triangle is isosceles, this side will also be 6 units. Now we can use this triangle to write the sine of angle 2 alpha. And that will be equal to 7 over 2 over 6. And that is 7 over 12. Now let's try to find the tangent of alpha. We can use some trigonometric identities for this, but we can also use this trick to find the same result. First, create a right angle triangle with 2 alpha degrees. Then we can find the missing length of this triangle using Pythagorean theorem as root 95. After this, extend the bottom line segment for another 12 units and connect the endpoints. Since we have created an isosceles triangle, these angles should be alpha degrees each. And from the large triangle, we can write tangent of alpha to be 7 over root 95 plus 12. Now we know the value of tangent alpha. Then let's create this right angle triangle to use that. We can see that these line segments should be equal to the bottom counterparts. So this part should also be 7 over 2 units. Now let's write tangent of alpha from this triangle as TP over 7 over 2. And that will be equal to 7 over root 95 plus 12. And from here, TP can be found as 49 over 2 times root 95 plus 12. Now focus on this triangle. We can apply Pythagorean theorem to find the missing side QR. And from here, QR will be equal to root 95 over 2. Now notice that the total of TP, X and QR is equal to one side of the square. So let's write this as an equation. This was the value of TP, and we have X and line segment QR. The sum of these values should be equal to one side of the square, which is 7 units. We can rearrange the terms to leave X on the left side. Now multiply both sides by 2 to get rid of the two values in the denominators. So we will have 2x equals 14 minus root 95 minus 49 over root 95 plus 12. After that, let's multiply and divide the last term with its conjugate to get rid of the root 95 term in the denominator. And this will give us the following term. Then we can simplify the minus 49 terms to have this equation. From here, root 95 terms will cancel out. And so 2x will be equal to 2 and x will be equal to 1. And that is our answer. Now let's start the second method. In this one, we will make some additional drawings, so let's scale down our figure. First, focus on this isosceles triangle and make a copy of this triangle on top of the square. And drop this perpendicular from point R to bottom of the square. Now focus on this isosceles triangle. We know that it should have equal base angles, so this angle will be alpha degrees. And so this angle can be written as 90 minus alpha degrees. Now notice that this angle can be written as 90 minus 2 alpha degrees. We know that these shaded triangles are the same. So this angle will also be 90 minus 2 alpha degrees. Now if you pay attention to this triangle and notice that both angles are equal to 90 minus alpha degrees. This means that this orange triangle is isosceles. Now if we call this line segment as y and this line segment as z, y plus z should be equal to 6 units because of this orange isosceles triangle. Remember that these triangles are the same, so this line segment will also be z units. Since this blue line segment in the middle is equal to one side of the square, x plus y plus z will be equal to 7 units. We know that y plus z is 6. So x must be equal to 1. I'll see you next time.